Hey everyone, Mrs. V here, and today we are going to learn about the technique of back titration, and in particular, we're going to learn how to do calculations with the results of back titration. So let's get our whiteboard on and get cracking. Okay, back titration, how is this different to the titrations that we've done already? Well, it's an indirect method. It means that you actually add an excess of reagent to the stuff you're analysing, and then you do a titration to find out how much didn't react. So this is a technique that's only used where the substance that you're analysing is insoluble. Now, you're going to have a tough time making a standard solution if the stuff will not dissolve. So if your analyte, the thing you're analysing, is insoluble, then you're going to need to use this method. Sometimes it's used when you're using a weak acid or a weak base, because it's really not possible to get a really sharp endpoint. So that can mean that it's very difficult to achieve concordance. So if you add a strong base or a strong acid and then titrate the excess, then that solves that problem. And the other one is where the solution being analysed is volatile. So adding excess can actually capture the gas before it evaporates. So what we have in a back titration is a situation where you might have a solid that won't dissolve and you want to analyse the purity of that substance. You're going to add excess acid, more acid than you need to dissolve that substance. And then a certain amount of it is going to react. So the crystals are going to react and it's going to use up this much of your acid. So this much here has been used up by reacting with the crystals. Of course, you don't know how much was used up. You need to do a titration now. So you do a titration to find out how much didn't react, to find out the leftover. Okay, sometimes if you've got a fairly large excess, you might make that up into a standard solution and pipette samples of that standard solution. So there's many ways that this can be done. However, when you come to do the calculation, you can follow a fairly simple set of steps to get you through. These are quite involved calculations. So the first thing you're going to do is when you initially just dumped a whole lot of hydrochloric acid onto those crystals, you're going to actually calculate exactly how many moles of acid that you added. Then this next step is you're going to use the results from your titration to work out how much of that was left over. So how much acid was left over after all of the crystals reacted with it. Then you're going to find the moles of your excess reagent fairly simply by taking the amount that was left over from the amount you started with. And that must have been the amount that reacted with the crystals. And then you'll use stoichiometry in the normal way to calculate the moles of the stuff you're analysing. So the best thing to do, I think, is just look at a worked example. Don't know why that's not rubbing out, but there we go. All right, so a 2-gram sample of impure limestone. Limestone is a rock that is mainly made of calcium carbonate, but this is impure limestone, so it's not 100% calcium carbonate. It's treated with 100 ml. Oh, that's terrible significant figures. Let's make that 100.0 so that we know the number of significant figures. Mil of 0.925 moles per litre hydrochloric acid. Now, I find it useful in these calculations to actually identify this is your total acid. So that's the total acid added. just identify the parts of the question that have to do with your steps. And then after the reaction is complete, 19.53 ml of 1.50 moles per litre sodium carbonate is required to neutralise the leftover acid. This is your titration data. So when you come to do the step about the titration, you have that data already separated out. And what we're actually trying to find in this is the percentage of calcium carbonate. It's also useful to remember what you're trying to find out. So if you highlight the question with those things, then you won't get mucked up when you're doing your calculation. All right, step number 1. Calculate the total moles of HCl. Now that we have all of that data highlighted for the total acid, it's simply moles equals concentration times volume. We have that already sorted out. We know that that's 0.925 times by 0.1000, which is 0.0925 moles. Okay, step 2. Step 2, we need to use the titration data to work out the leftover hydrochloric acid. So luckily, we've highlighted in the question where exactly our titration data is so that we don't have to scan the whole question every time and possibly get confused. So we want to find our known here is sodium carbonate. So we're finding our moles of sodium carbonate. So that is concentration times volume, which is 1.50 times by 0.01953. And if you run that through your calculator, you'll find that that is 0.0293. Okay, now we need to use a mole ratio. And of course, what we should have started with was a balanced equation for this reaction. So we have a reaction between sodium carbonate. Don't get that formula wrong. That is mixed up so many times. So our equation there is where we're going to get our mole ratio from. So we want our mole ratio of hydrochloric acid to sodium carbonate. And that's equal to 2 to 1. And of course, a little bit of algebra tells you then that the moles of hydrochloric acid is twice the moles of sodium carbonate, which is twice 0.0293, but you're not going to use 0.0293. You're going to use the full answer in your calculator before you round it off. Okay, when we round off to the correct number of significant figures, that's only when we write things down. When we continue the calculation, we use the whole answer. So multiplying that by 2, we get 0.0586. Okay, so that is our moles of hydrochloric acid that was left over. Step 3 is to find out how much of the total actually reacted. So this is the moles HCl that reacted with our calcium carbonate crystals. And this is simply taking the total amount we added and subtracting what was left over. So the total amount we added was 0.0925. And the amount that was left over was 0.0586. So the amount that actually reacted then was 0.0339 moles. And again, you would use here the full answer in your calculator, not the rounded off answer of 0.0586. All right, step 4 now. We're getting close now. Step 4, we're using a different reaction. We want to find the moles of calcium carbonate. And we're using a different reaction now. We're using the reaction of calcium carbonate with hydrochloric acid. So we're working with a different mole ratio, different reaction. It's very important to make sure you know which equation you're doing the stoichiometry with. So we want the moles of calcium carbonate, sorry. So its mole ratio with hydrochloric acid, which is what we know, is 1:2. A little bit of algebra will then tell us that the moles of calcium carbonate is half of the moles of HCl. So that is half of 0.0339. But you're not going to use 0.0339, you're going to use the full answer in your calculator. And this is going to give us 0.0170 moles. Now you might go, fantastic, now I've found the moles of calcium carbonate. But that is not what the question asked for. The question asked for the percentage of calcium carbonate. So you're going to need the mass of calcium carbonate for that. So let's determine the mass of calcium carbonate, which is moles times by molar mass. So our moles is 0.0170. But of course, you're going to use the full answer in your calculator. And we have 40.08 for calcium, plus carbon is 12.01, plus 3 oxygens is 3 times by 16. And that will give you 1.70 grams. And you might think, yes, we're done, but we weren't asked for the mass of calcium carbonate, we were asked for the percentage. So we've got one more step to go. The percentage of calcium carbonate in that limestone is the mass of calcium carbonate over the mass of the limestone sample, which was 2.00 grams times by 100. And that gives us 84.9%. So there you have it. These are quite involved questions. They would be worth a lot of marks in an exam. That's all for today. If you found this explanation useful, if you found that you understand back titrations just a little bit better now, then please consider giving this video a like. And also, for more explanations of lots and lots of aspects of chemistry, please subscribe to my channel. I am going to see you guys in the next video.